I've been using neural network to train my AI agent, precisely DeepQ neural network, and for the optimizer I've been using SGD aka stochastic gradient descent. And if we look at TensorFlow's documentation on optimizers section, we see several optimizers we could choose from, such as Atom, variants of Atom, RMS prop SGD. This is the one I've been using, and I did some research, but SGD is not suited for ML tasks involving reinforcement learning, but Atom. And the reason is that in general, reinforcement learning, specifically in the beginning of the training, is really random and unstable and noisy, which leads to unstable, noisy gradients. When you're training neural network, you'd want to minimize your loss function to by converges to global minimum. But since the reinforcement learning is so unstable and noisy in the beginning, you might end up stuck on local minima instead, which is which is a bad situation. And since learning rate would be fixed in SGD, once you stuck on these global local minimum, it's hard for you to hard for neural network to escape from it. But if you use Atom, you might be able to escape from it, and Atom just adapts gradients based on based on based on how big or small the gradients are. For instance, Atom makes the gradients smaller when the gradients are big, and vice versa. Anyways, I just I've started using Atom for the optimizer to train my neural network. So this is how I train my neural network. I compute or process for the propagation for the Q network and the Churget network, and later I do the backward propagation, and the backward function looks like this, where I compute the gradients of loss with respect to each parameter's weights and biases, and after that I update weights and biases by multiplying these gradients with learning rate. This is what I mean by this is how things are. I mean, parameters gets updated if you're using SGD. The learning rates are fixed, but this is how things get updated when you're using Atom. So it's you multiply learning rates with things not fixed. You wouldn't just multiply by raw gradients. So before I only had weights and biases, but for the Atom I need to initialize weights and biases for biases used for the Atom calculation or computation. And these were initialized so that they would have same shapes as weights and biases. And these are also parameters used for calculating the yeah. And this T stands for time step. It gets incremented every time this function, every time you update, every time you try to update weights and biases, or every time you use Atom. This would be useful later. So M stands for mean or average. So which means in SGD you just use the gradients, but in Atom you compute the moving average, or I mean just average. Notice the value for the beta 1, it's almost 1, which means this M, and for this one I subtract beta 1 from 1, which means this would be really small values. I mean 0.1, so which means this M's contains mostly the previous M's, and you add with the current gradients. So yeah, this is how you compute the average. So M's are just average or mean of all the gradients you've been calculated up to certain points. And B stands for variance, but this is not same variance as used in mathematics. And this is just squared version of this. Notice the only difference is that I use beta 2 instead of beta 1 and square the gradients. And this B just indicates how big the gradients are. And after that, I use these M and V's to compute what's known as M hats and V hats. This is just to correct biases, because so here I divide MW3 by these things, right? And the reason is that these are all initialized to zeros, and in the very beginning of the updating, in the very beginning of when this function gets called, this is 0 and you multiply by 0.9, so these are all zeros, and this would be also 0.1, and you multiply by gradients just computed. So MW3 would just be this gradient. And yeah, if you didn't have this, it would be this. But these gradients are so small, and you don't, and it might be end up in bad results. So in order for not to be like that, you multiply by almost identical value as this. When the first time this function gets called, t is 1, so this is exactly same as this value, so this gets cancelled, these would be cancelled out. So yeah, and you'd end up just having this gradient, which wouldn't be small because now you're not multiplying by 0.1. And when after you calling this function many times, this t gets bigger, and so that, and when after this gets bigger, this would be almost 1, which means M hat would be just this MW3, which just considers the average of all the gradients. And this just the same things goes for B hat. And at the end, so this epsilon is just to not, to avoid dividing by zeros. And this square root means, I would have square root for the B hat, and I mentioned B hat is indicates how big the gradients are, and I square root, which means it is inversely proportional to M hat. So when the gradients are so big, these values would be small, but when the gradients are so big, small, this would be big value. So this is what I mean by adapting based on the gradients. And this is how Adam changes the gradients. So this is the atom. So I also changed how the hydration system works. It works like more realistically. So I did some research, but I noticed that people don't really die after certain time of after he's been dehydrated for certain days. He would gradually dies, and this is how I computed. This is how I implemented so that he would die gradually. This is some kind of integral. Yeah, I also changed how fast he walk and run. Seems like average human walk speed is 1.4 meter per second. So maybe run speed is double of that. And I also change based on his energy states. If his energy states is less than 0.15, the speed would be half of these. I don't know if you guys noticed, but I'd had a predator entity, but I wanted to make my world a modern city, and you wouldn't see entities like predator in modern world or modern city. You might find birds or dogs, but you don't. So I just removed the predator. I'm not really sure if I'm gonna add any kinds of animals at the moment. I think this is pretty much it for today's update. It was most likely the Atom optimizer. For some reason, I wasn't able to get things done past week for some reason, but anyways, I think until next time, as always, thanks for watching till the end of the video, and thanks for all the supports, and I'll see you guys later. Thanks.